Okay, so next up, I want to welcome to the stage Viktor Vedmich. He's a developer advocate at AWS, coming, I believe, second time to Uzbekistan, right? The second time.
Second
Please
time.
welcome Viktor Vedmich. Before we start, Viktor, so this is your second visit. Can you please tell us how do you like our country? What do you like the most? What's different this?
It's very difficult to say something, like after I watched this amazing video, that's how many interesting places do you have and how you grow fast. Interesting fact, it's maybe my personal opinion, but previously when I arrived to Uzbekistan, to Tashkent 1 year ago, it was exactly 1 year ago, I see currently you have grown very, very fast. So I expect maybe next year when I will arrive, I hope you will invite me, yes, Ahmed, for next year. Of course. Thank you, thank you. Yeah, so I am really, say it's honest opinion, excited how you grow fast and how everything is changing around. Like previously, I remember I made some joke that you have only one car across the whole country, and like 99% of the people driving only using this one car. In this year, I see like you have a choice what kind of the car, electrical car and so on. Yeah. It was not a joke, but yeah. Yeah. So my name is Viktor. I am developer advocate. So it means like I try to help you developers to grow and sometimes be like your advocate on the side between the customers, sometimes between the business, sometimes between the project management, and help you to figure out something new. So my session today, very, very interesting. But before we started, I have some special prize. I know that for best question we have a license from JetBrains, but as we have resilience architecture patterns, I also bring some stuff from AWS. It's builder cars. Ahmed already mentioned that if you don't like my talk, you can stand up and go and play builder cards. But if you like it, so you can ask some questions and you will have some special editions of builder cards. So, before I joined AWS, I worked for EPAM more than 10 years. It was an amazing experience. Thank you. And all time it was very, I was a person who works on production. I mean, I was a person who was responsible for big productions, like one of the customer, 10 million users. So it was incredible experience. And all time it was a big question, how we can make our application more reliable, more resilient, highly available, and all of the stuff. So for that reason, I decided to speak today with you about resilience architecture and some patterns, what you can apply and how you can do this resilience architecture in your application. But before we I see, I know, currently I understand what's happening. So, but why it's so important? So, first of all, most probably the main answer will be the money. So let's look at the statistics from IDC. If you're part of big companies, like from Fortune 1000, based on the latest statistics, during the year they lost more than $1 billion only for downtime. It's huge numbers. Also, for 1 hour, for downtime for these big companies, it costs around $1,000. It's also incredible number from money perspective. I can buy so many BYD or some other cars. So, but it's huge numbers. But another point, it's not only related to the money. It's also related to the branding. So, for example, you want to buy a ticket and you cannot do it. How you will rely on this application, on this business for the next time? So big question. So it means resilience, it's very important in nowadays, especially when we moving, from our mindset that all of our applications currently should be available every time. I mean, if I do something, this application should be available always on. It's mind shift of our, mindset inside of the clients who work in these applications. But I see we have 3 different main carriers. areas when we want to create our applications resilient. So high availability is like where we're working on our applications and make sure it's available at every time. Disaster recovery, if something happened, we can restore and provide access to our application as soon as possible. And for sure, like continuous improvements. My favorite was like continuous because we have to continuously learn something new. It's one of the reasons why we are here today. We want to learn something. And the same stuff we have to do it in our applications. So high availability, disaster recovery, and continuous improvement. But how I can do it in cloud solutions? So first of all, when we create something in the cloud, we need to understand that it's all time in cloud, you shared your responsibilities. What this means, like, for example, in security, AWS all time, it doesn't matter AWS or other cloud provider, we say like, we have shared responsibilities. We're responsible for like core infrastructure, like for example, the hardware, networking, and everything stuff. Like this is our responsibility. But you also responsible for other part, like how you provide access, for example, to your applications, where you store some secret data, do you encrypt this data and so on. It's related to security. The same stuff, it's from sustainability perspective, because if you consume too much resources, most probably your applications is not very sustainable. And we have absolutely the same approach when we speak about resilience. But when we speak like what exactly in AWS, we as AWS try to provide it for you, this part of responsibility on AWS side. So first of all, it's our culture, how we create all of the applications. You know, like, my favorite quote from AWS, it's from Werner Vogel, you build it, you run it. It's exactly how I understand what DevOps is, because when we create our service, it means like the service team fully responsible just to create this application, develop this application, deliver these applications, maintain these applications all time. It means like when you, you know, like recently I figured out interesting like statistics that service team mostly spend only 30% for new development. Other percent, like it's supporting and continuously growing the application. So you build it, you run it, it's our responsibility. So when we create our applications, it's our ownership of the service. The next one, it's operations readiness review. It sounds like super easy, but I see so many times people just like ignore this part. What exactly is? So, for example, when we want to deliver a new application or new functionality, or just like super small changes. Anyway, we have some checklist. Like this service is ready to be on production, is ready for our customers, is ready to be deployed across multiple availability zones, regions, and so on. It's just like questions list. That's how we do it. It's our experience. I mean, like how AWS doing for every applications. The next one, it's started like safe continuous deployment. So we try to minimize effect. It means like when service team want to deploy something new, we started from very small piece. One server, one instance, like if it works correctly, we're moving on to the next one to scale to, for example, availability zone. After that, like availability zone is good, we scale to the whole region is good, and moving on to the next one. And the last one, it will be related to corrections of error, the process. So what is it? It means like if I figure out that during the deployment we have some issue with deployment process, with our code, with infrastructure, with dependency, and so on, blame us culture inside an AWS and try to figure out what's the root cause of the problem. That's how we try to create resilience of the cloud. But when we speak about resilience as shared responsibility, I said we have two different parts. AWS part, like my part, yeah, so it's like how we did it and how you should do it to be more resilient. So there are four main part. The first one, it's like it will be anticipating. Anticipating, it means like you try to understand what inside in your code. Try to make it work correctly without some bugs, without any issues, problems, security problems, and apply different part of the patterns, which I will describe a little bit later. The next one, it will be it will be observability or monitoring to figure out what's going on with our applications. The next one, it's learning. So we learn what we are doing with our applications, how it's like responding to our, like to our request and so on. And the last one, we learn what we did, learn how it works. Like for example, in the previous our sprint, we did some mistakes during the deployment, or for example, currently we depending on third-party applications, and these applications is not works correctly. So this is how we can do resilience in cloud. Your applications can do it in cloud. So it's a whole wheel that we proceed and create resilience applications. So the first one, but what kind of the problems can happen in the cloud? The first one, it will be related to the code deployment. So continuous integrations, continuous delivery. Kostya today spoke about that, like how you can do it and integrate some generative AI. But again, in my experience, based on my 10 years to be as DevOps engineer, I know that sometimes sounds like super easy to do continuous deployment, for example, but in reality, it's so hard to do it in the correct way and avoid mistakes, problems, errors, and some fails during that. So the first part of the failures will be for sure, it's like your continuous deployment. The next one, it's your infrastructure part. So for example, you have one of the server. Honestly, I had this experience. We put some of the critical part of our application only on one server. And you know what happened on one of the day? So this server was broken and like failure for the whole system. So try to be prepared that if you do something, like create in highly available solutions, not rely only on one server. Data, the next part. Databases and general data, it's very difficult questions because data is like the new type of the gold, new type of the gas. Because if you own some data, most probably you can use this data. And if you lost this data, you not only lost some money, but you can lost the how people rely on your application. And the last one, it will be not the last one. The next one, it will be dependency. Dependency from third party. Third party of applications, like for example, you rely on payment system, and this system can be not currently up and running, so you have to be ready to make sure that, like, if something happened, for example, you can postpone of the payment or something like that. And the last one, it's what you cannot predict or forecast and say, hey, potentially we can have some problem with this part of the applications or this part, like house engineering in general. You cannot predict that AWS, for example, one of the region will be go down based on, I know, some natural disaster. Yeah. So that's how you have to be prepared. And the main question is how we can be prepared for all of this stuff. My main answer will be well architecture framework. That's what you should do. So who familiar with well architecture framework? Please raise your hand. At least you're not sleeping. 1, 2, 3, 4, 5. Couple peoples. You don't know what is? Yes, you know. Anton, please. So well architecture framework. Super recommend. Honestly, it's not like a big book which you have to spend like weeks just like to reading. It's like it's maybe 50 pages. You can read and understand what's going on. In well architecture framework, we have 6 different pillars to explain you what the best practices. We created this well architecture framework based on experience with our customers. I mean, we have multiple customers, like thousands of the customers. So this is what we put everything in one place and share it with our customers to make sure that you do your applications more stable, secure, reliable, and so on. But one of the part, like one of the pillar of the architecture, for sure, it's resilience. So reliability. And so what kind of the steps here? So first of all, test procedure of recovery. Like you know, how often we create a backup and never test it. How often we rely on our backup solution, but in day X, when really something happened, we try to restore this data, we try to restore these virtual machines, and we figure out that it does not work. So try to test, at least test what are you doing and test recovery procedure. So it's very important part, not only to save the backups, but also to test it. Stop guessing what your capacity is. I mean, for example, we expected that our users will be around 200 requests per second, but in reality, it's only 10 requests per second. The biggest benefit of cloud is like provide for you just-in-time resources, what you exactly needed. Stop guessing. Look at the monitoring, look at your data, how many requests you get it, and provided the right resources inside in the cloud. So the next one, it will be operations excellence principle. You know, again, like I will rely and make a reference to Anton. So if you can create operations or in general infrastructure configurations as code, you will be on the next level. It's a game changer because you can control and reproduce everything super quickly and manage everything as a code. So it's very important nowadays to do as much as possible as code, not be a click ops when we open the console and make some, you know, like operations and forgot what exactly the step was and so on. So make the failures, like refine your operations procedure. It means like you create the guidebooks, what's need to do in case if something happened. So it's make us reference to how we can be resilient in the cloud. 4 different steps, but let's go to deeper in everyone. So we have anticipating, monitoring, responding, and learning. And for sure, we will start from anticipating. What exactly anticipating means? So we need to make sure that our code looks good, not only from a bug perspective, but also be prepared for some different type of the failures. Our code is cost effective. Why it's so important? Because sometimes we create not optimized code on our applications and just consume the resources which we exactly not needed to proceed all of requests from the customers. Good story from AWS. Again, I will reference this a little bit data. It's a little bit, I would say, outdated, but it shows you exactly how you can grow and what you can do. And also I will provide like fresh data. In last year, we spent more than 100 millions for 2 days, for Prime days, Amazon Prime days. And in 2018, guys in AWS proposed to use Amazon Code Guru to review the code on Amazon. Inside in Amazon, we have thousands of the applications, and based on the optimizations what we provided, we saved like more than optimized utilization from CPU perspective 300 plus optimizations, and cost effective like less around 40%. So cost of this Prime Day was on 40% less compared to the previous. So Code Guru exactly can help you to do almost the same. So there are 2 main points. The first one, it will be reviewer. Reviewer is like review what's you written, like it can show you where some codes can be huge utilized of the CPU, for example, and maybe you write it like smells, bugs, and so on. It's the first part. And the second part is like to start to write your code. And the second part, it will be a profiler, where review exactly in your build and your applications and visualize what's going on with your applications and help you to figure out where you have potential issues. So yeah, so optimize, detect, all of the stuff. You know why I made some pauses? Because sometimes I see this refresh a little bit longer than I expected. Okay, so the next one. The next one, please. Yes, here we go. What kind of patterns you can apply in anticipating stage? So there are main 5 main patterns: back off and retry, circle break it, grateful degradation, throttling, and load shading. So let's look at the real example. So for example, you have your own applications. It's microservice applications. For example, to make a booking of hotel, like for example, when I arrive to Uzbekistan, I need some hotel to live during the community day and all of the stuff. So it's just like super typical architecture. It's my travel buddy, for example. What we have here? So we have hotel reservations, we have flight reservations, payment, because we need to pay, reward, trip, and recommendation services. And just like imagine the situation that you have an issue with networking. So if you would say, like you stay on your computer, most probably you will push the button of refresh, refresh the pages, try to make the retry and get this information from the applications. But in reality, when we create this architecture, we have to apply this, this pattern to make the retry, especially when we are working with microservices. Retry, it's very important. And there is some example how you can do it. But most important part of the retry, make it retry with backoffs. So it means like you not retry every 5 seconds, you increase when you will do this retry for the next time. There is an example of the code on C#, but you can do it on Java, JavaScript, up to you what you prefer. It's super simple, you can do it super easy. So the next one, service throttling. Service throttling, and here we go. Yes, service throttling. So, for example, imagine I have my reward service, and this reward service currently have an issue. So maybe I not need to proceed all of the requests currently. Maybe I have to postpone and say, hey, can you please stop to send me some request? This is where we can apply this retry policy. So, and most interesting fact, when you work in microservice architecture, you should fully understand that when you create this retry, depending on other services, you create this coupling of the architecture. In microservices, we prefer to make it a decouple architecture. So it means maybe we have to do this retry and backoff outside of the applications and can be applied in step functions. For example, you create this loop and the logic, what you should do, how often you need to make this retry and waiting for the next step. So the next pattern, for example, you have a recommendation service, and when you make some reservation of your hotel, it's like synchronous call. So you call everything. So it means when the user want to make reservation of the room, you call the hotel services and recommendations. But in this period, the recommendation service has some issues, cannot respond as quickly as we expected, and we can see the timeout of the whole applications. But at the same time, we proceed with new requests, and hotel services make the connections for the users, for the new clients, and we consume these resources. But at the same time, we cannot finish this request. We're waiting for when our high latency recommendation service will respond for us. And you can expect what will happen the next. For sure, we'll have more clients who want to do the same stuff, to make more requests, to make reservations. And our service team tried to solve this problem. But what we can do in these situations, because we have high load or a lot of pressure on our applications, recommendation services, and at the same time, we cannot fix it because it's continuously we have new and new requests. So circuit breaker can help us in this situation. So we create a logic as soon as we understand that our service currently is not stable, is not response as how we prefer. For example, we get a lot of 500 errors. We can close the connections to our service and provide this time for service team to fix it. So how it will be, looks like on an example. So for example, first time I have a timeout from my recommendation service and I open this circuit breaker. So I open, I create the connections to my hotel service, but close the connections to the recommendations. I open the circuit and don't send any request currently to recommendation service, which helped me to provide the time in recovery time for recommendation services and for the team who can fix it. But at the same time, circuit breaker also do a regular check that my recommendation service currently up and running and can respond to my request. As soon as I have this request, I can restore and make these connections again to recommendation. So close as soon as I get some error, and open as soon as I understand this works correctly as I expected. So how it will be implemented, again, like from architecture perspective? Most probably you have to do it again outside of your applications. Step functions, you can do it super easily. So you create this very quickly, logic, open the circuit breaker, make this check of the connections to your servers through the step functions for the Lambda, check that your service is working or not, close or open circuit breaker depending on what the current state is. Okay, the next pattern, create isolations or cellar of your architecture. So, for example, you have your instances of your applications in one place, and the connections to the application have to go through the front door. Front door, like for example, your load balancer. And if something happened in this area, in this cell, it means like you affect only this availability zone, this instance, this instance of your applications. Why it's so important? Because like you can scale, you can grow, and for example, spread between different regions, between different data centers. For example, you also can apply in your on-premise solutions, but at the same time, you not create this blast radius that if something happened, you lost the whole applications. You will lost only one of the instances, of your applications or a cell. So create a cell architecture as a single region. Try to avoid connections and coupling to some global infrastructure. And it brings us to soonest possible router, where create like connections between different instances, and most probably you as try to create some highly available solutions, you try to create like spread your load between different availability zones. And for example, in this case, I have one availability zones or one region and another one. And in some case, if something happened, I can switch to another region. But how we can do it, I mean, like how we can deploy our applications without affecting the users. So exists a couple of patterns. The first one, it's create fractional deployments. What this means, like you try to minimize effect on the users or deploy new version of your applications without downtime. And what interesting part of this fractional deployments that you create this infrastructure from the scratch. When we create it from the scratch, it means like we apply immutable infrastructure. Never ever create infrastructure and make updates on this infrastructure. It means like you will have some configuration drift. Immutable infrastructure, it's not something new. It was created, it was released in 2020. No, it's 2013, 11 years ago, this pattern. So immutable infrastructure is very important part. But still the question is how we can create like zero downtime deployments, what kind of deployments in general apply and reflect this pattern. So currently in the market exists different type of deployment strategies. The first one was highly not recommend, it's recreate, so you stop and create from the scratch. It's immutable, apply immutable infrastructure, but at the same time, you will have some downtime. The second one is rolling update. Most probably you're familiar if you have ever tried to play with Kubernetes or with AWS. Rolling update is super popular. Blue, green, and canary. You know, like some time ago, I decided to figure out why it's called canary. And interesting story about the canary deployment because it's brought it from the miners from the Spain. Miners, not like Bitcoin miners. It's real miners who go underneath and do some stuff. So it's like try to mine real stuff, not like Bitcoin. So why canary? Previously, when people tried to check the quality of the air inside in these places where they work, they put the canary, and if the canary is still alive, it's still breathing, it means like it's good quality of the air and miners can come in. So it's reflects to the same approach what we have in IT, I mean like in our deployment process. We send only 5% of our real traffic to new version of application, and if this application, if our instance of applications works correctly, most probably we can transfer all other law to new version, like 5% or 10%, up to you, but it's apply two main approaches: immutable infrastructure, so we create a new version of applications, and the second one, zero downtime deployment. Highly recommend to apply canary deployment in your applications. But what about if I, like have some disaster? What kind of strategies do we have to make disaster recovery faster and quicker? Again, it will be dependent how much money do you have. So from the left side, it's like you have some backup for sure. You have to have some backups, and you test the recovery of these backups. But it will be the cheapest one. And the last one, it will be like active solutions, where you have a both instances active at the same time. And in case if something happens, you just like switch to the, like not switch, moves other traffic from previous version to new one and continuously proceed. So zero RPO, RTO, but please pay attention to the money. Sometimes it's very difficult to implement and it can cost like a little bit more to compare to the standard backup and restore solution. So how we can see what's going on with our RPO, recovery, state, and so on. In AWS, we have interesting service. It's Resilience Hub, which combines inside in the Resilience Hub a lot of interesting informations. First of all, it will show you what's the current state of RPO, RTO. You can run continuously this test in your continuous integrations pipelines. For example, to test recovery procedure. I already said it. Test your backups. Make sure that you can recover from backups. So in the resilience architecture, in the Resilience Hub, you can test it. Your restore procedure will be your own, so it's your responsibility. But in the Resilience Hub, you will see what's going on. Also, in Resilience Hub, you will see some recommendations like availability zones, maybe provide some changes, what you should do inside in your applications, and for sure some operations recommendations, how you can make it more efficient way. So this is how it looks like resilience in the cloud. And we finish only with the first part, is only with anticipating. Let's move on a little bit faster because, no, we have time. So to monitoring. Monitoring in general, it's very interesting, it's very important stuff in your applications. I would say it can be split on 3 different areas. The first one is detect, and where we spend most of the time and money and branding of our applications, because we can detect that we have an issue during the long period of time. So your monitoring have to be very quickly to say like, hey, you have a problem. And this is a problem with some of the services, not of CPU or something like that, with your services. Investigate. Monitoring can help us to investigate why this happened, what's really happened, what I should do in these situations. And the last one for sure, like what's the response? Using the monitoring, the good monitoring solutions, we have a response to make sure that we fix the right problem, the right instances, for example. What's our philosophy of monitoring? I mean, like in AWS, first of all, measure what's customer care. So who care about CPU load on your applications? Who care about how many requests do you have? For example, I'm not care when I make a booking of hotel that they have currently 99% of CPU. I'm not care. I'm as a customer care that I can make reservation of the hotel. I can pay for this hotel, for example, or finish my transactions. This is what you have to measure in your applications. Measure what's exactly important for your users. So it can be, for example, latency to response, success of the response, like 200, 500. So measure what's really important for the users. Detect and response when you have an issue. So it's very important. But how, what kind of metrics we have? So the first one, it will be health metrics, which say, am I healthy? It's not answer to the questions, why, like what's happened, why I'm not healthy. It's only answer the questions. Am I healthy? My service currently is working correctly. I can proceed with the new request. Can I make these reservations or not? Only in this way. And another one, like diagnostic metrics. In diagnostic metrics, you can collect other stuff and to show that why this happened and help you to make this response quickly. So in my experience, I would say you have to implement some synthetic monitorings. So when you create external requests to your site, and that's not like only this, like I can proceed and see 200. Make some very quickly test, and I can log in. I can leave some comments. I can do reservation. I can, for example, rebook of the reservation and so on, and make it continuously monitoring. It should be part of your monitoring solutions as usual, like in a continuous way. So what kind of real user monitoring exists currently? So client-side telemetry, when you send like end-to-end monitoring, like a real user make reservations, finish these reservations, and continuously measures the impact on the user. For example, you have issue with recommendation service, how it will affect your user, especially in real monitoring, in real end-to-end testing of your applications. And make it debug easily, because when you have an issue, you need to very quickly to figure out what's really happened. But when we speak about monitoring, it's split on 3 main areas where you can do it. So like main questions about the monitoring, how to implement, how I can do in my environment. So you have to collect and like respond on 3 different areas. The first one, it's a metrics. Again, these metrics can be different. In AWS, we prefer to collect the metrics which is important for the customers, not only CPU and memory. The second one, it's logs. Collect the logs, what's happened in your applications. The third one, it will be the traces. Traces will help you to quickly to determine what's happened, why this happened, and what's the dependency to other applications. So from observability suite, we have different services like CloudWatch, one of them, X-Ray, logs, metrics, events, Lambda Insight, containers inside, all of the stuff. But for example, I'm more prefer to work with open source, and for sure you can do it in your own way. So do like DIY, so do yourself. So you can do it through the Prometheus, for example, Grafana, and all of the stuff. Like observability stack, it's very huge in AWS. But like one of the biggest problems with monitoring and observability, it's fake alerts. It can be a really big problem, because when you have a lot of like alerts and you start to ignore all of them. So for you, alerts like 100 emails per day, and maybe one of them is important, only one of them important. And here Amazon DevOps Guru can help you to do it. So in DevOps Guru, we try to implement machine learning, generative AI approaches to figure out what exactly will be important for these alerts. It's real, it's a fake. Do you have a really, for example, security breach, or maybe it's like it's normal situations and so on. DevOps Guru collects the data from multiple sources and proceeds through the machine learning, again, generative AI procedure, and send to you what's really important, not only fakes and not important alerts. So it was monitoring. The next one, how we can respond to if something happened. So in general, you need to create some response plans. So for example, you have an issue with deployment procedure, or if one of the database is broken, what are you going to do in these situations? So in System Manager, Incident Manager, we have like the 2 main parts. The first one is response plan. The second one is incident dashboard. It's your responsibility to create the plan. How are you going to restore? What are you going to do if database is broken? And this should be written on the, on the paper, because when you will wake up at 3 a.m., for example, you need to do it super quickly. So be prepared for this. I mean, like, if something happened, be prepared. Prepared you know what you should do in case if something happened. Monitor and detect it, because I know some statistics that's between when the incident happened and when we exactly identified this incident, most probably it will take around 15 minutes or longer, because people not like have good monitoring solutions and not quickly response of this problem. And the last one is response. Response on your incident. Create the runbook, create instructions what you should do. But also you can do it automatically. So this is the pattern how you can do it. The first one, it will be event-driven response pattern. Super easy. So for example, you have issue like someone decided to make a changes on your security group. And what you can do, like it's event appears in CloudWatch, and we can go to Lambda functions and fix it. So it will be looks like on this way. So some of the developer go to security group and say access to my database from 0000/0. So it means like the whole internet can access to my database. It's not in the right way of the configurations. Monitoring detected, sends the event to Lambda, and Lambda proceed and close this event. So, or for example, how in this situation is like S3 bucket. This is the next one, so I'm a little bit mixed. So the next one, it will be SSH access. So a little bit quickly, but another interesting part, it will be related to how we can detect that something happened in my availability zone. Sometimes it can be very terrible to identify it, because availability zone, just remind you, it's one or multiple data centers, and when you need to, so for example, pause traffic to availability zones, you have to do it like manually. But currently you can do it through the zonal shift. So based on ILB and NLB, we have internal system which said like currently some electricity outage, for example, or air conditioner outage in availability zone A, B, C, for example, and stop sending traffic to this availability zone. It's also how you can create more resilience of your applications. So it was monitoring. So the next one, it will be learning. Learning what we learn and how we can apply what we see in our applications for the future release, for example. It's very important to do it continuously. Continuously of learning. You know, sometimes people ask me, why it's so hard to join to IT? My answer all time said like, it's not too hard to join to IT. It's harder to stay in IT actual. The same stuff happened in the learning. In general, in your applications, you need to learn what really happened. And you know, like Jeff Bezos is, I believe all of you knows who is Jeff Bezos, said, good intention never work. You need good mechanism. The key word here is mechanism. Mechanism, like you never should rely on the people. So, for example, I am as a person make some mistake, and like what's the guarantee that tomorrow I will not do the same mistake in the future? No guarantee. Only mechanism can help us to prevent this problem, prevent this issue. And we call it correction of errors. It's a mechanism which we try to apply across our services and highly recommend to you to create your applications, to create your architecture more resilient. What exactly it means? So, blameless culture. You never need to say, hey, you have you made this mistake. Every time be prepared that all of us is still human and we can make this problem, but we have to be prepared and focus why this happened, what the technical issue was, what the process, what the takeaway from this problem happened, and how we can do it, what we can do to prevent it in the future. Maybe some documentations, maybe some automations patterns, what I showed like previously, close access to SSH, for example. If we look at the autonomy of corrections of errors, it will be split on different areas. So first of all, what's the summary of the problem? Like, we had an outage of our productions. Why? Because availability of zone was broken on network connectivity. Maybe someone opened SSH access and currently we lost access to the whole event, to the whole productions. So summary, impact, what the timeline was, what the metrics. Try to apply 5 whys in your corrections of errors. So every time you not only ask why this happened, you ask 5 times to go deeper and deeper to find really the root cause. Make an action items, what you will do to prevent in the future, not only to say, hey, Vita, can you please be more careful for next time? No, it will not work. Make it as automation process, make it a procedure. For example, runbook, checklist, what I showed you how we release to production. And another part that can be interesting, it's chaos engineering. You never know what will happen in the future, but chaos engineering can help you to, to make some unpredictable event and be prepared. You can prepare yourself in these situations. It means like, for example, if connectivity between web applications and your database will not be very stable, or we lost connectivity to the DNS server, what will happen? Chaos engineering can help us to answer on that. And chaos engineering is engineering practice because it applies some mechanism. And maybe you're familiar. If not, I will very quickly to explain what the fate is in chaos engineering. First of all, you have your steady state. Steady state, it's what's your baseline of application, how it works, what's the connectivity, what's the user wants to make the reservation of the hotel. Should it connect it to recommendations or to the payment system and so on? So steady state, what's the normal situations? Make some hypothesis. So you create, so for example, if I lost connection to my recommendation service, or it will be high load of recommendation service, how it will affect my applications? You create this hypothesis, run experiment to this is experiment, it's a real experiment. You try to, implement what's your hypothesis, like what's your experiment. We lost connections to recommendations. So run this experiment, verify that your experiment works correctly, how you expect it or not expect it, learn from that, and for next time to improve, continuous improvements. So you continuously try, repeat, improve on the next state. If you lost connectivity to database, to DNS, response of the network slower than you expected. This is how you should do in-house engineering. You can do it again in Resilience Hub with a service which called Fault Injector Simulator, where you can super easy to install this scenario of your hypothesis, experiments, and look what's really happened. We continuously add new functionality. So, for example, currently you can create broken between availability zones, regions, and so on, or super easy implementations of problem with DNS, databases, a lot of applications. Very, very easy and quickly to do it. And what is most important part of house engineering, if you want to do it in your own way, in your own open source solutions, please create safeguards. Safeguards like you control where your house engineering is going on. So it means when you push the button, you will not broken the whole production. You will just affect exactly what you expected, not going down some database, for example, and so on. And also in AWS, we have a separate culture and approach, which we also highly recommend to do it. It's game days. It's not AWS game days in what we did yesterday. I mean, practically try to learn something new. No, game days here is the patterns when you simulate this problem inside in your production system. Because I was on call during my career in EPAM. And this happened every time at 3 a.m., honestly. If something happened on productions, it was a call 2 a.m., 3 a.m., 4 a.m. I don't know what's about you, but me at 3 a.m., sometimes I'm not ready to read documentations to figure out what I should do in situation A or B. Try to make this muscle memory. When I say muscle memory, it means you create this scenario during the normal working day. You know that, for example, Ahmed, Dazik, and Viktor responsible for this problem on productions. And try to simulate this issue, maybe not on production, but maybe on staging, and go through the whole procedure like it's real game day, that you see that you have problem, what's the procedure to recovery, how it's impact on the users, and what you should do to recover to the normal state. Simulate this problem on your working days, not on the production. So it was resilience in the cloud. So again, the main takeaway from my talk, try to remember there are 4 main key areas. Anticipating. So learn what you have in your, I know, 10 minutes, I know. Look at your code. Make sure that you apply patterns like timeouts, back-off timeouts, throttling, circuit breaker. Look at how you consume based on CPU utilizations of your code. Static code analysis, so from AWS solutions can help you super easy. Monitor your solutions. It's very important part because when you have some downtime, you need to be prepared for that and detect as soon as possible. Not end user should send you email and say that you have an issue in your productions. You have to be the first person who figure out that you have issue on your production system, for example. Responding, not just like to create a ticket that we have an issue. Create a run book, create a procedure. Be very careful with alerts. If you're not ready to be careful with the alerts, use DevOps Guru from AWS, can help you. But my experience showed you that for every alert, what we create in monitoring stage, you need to create some run book or procedure like documentations in responding stage. Response, what you should do in case if something happened. And learning. Continuous to learn, make a muscle memory, how you need to do, what you should do in case if something happened. That's how you can create your resilience architecture, resilience of your applications. Thank you very much, and super welcome if you have any questions. And want to just remind you that I have some special editions of Builder Cars. Builder Cars, it's table games, card table games, and it's super interesting. Highly recommend, especially if you want to learn AWS.
And we also have our user group booth on the first floor where you can try to learn how to build, how to play the builder cards. Yes. The first question.
I see this person opened the book, and please, not more than 10 questions. Okay.
First of all, I want to thank you, Viktor, for your exciting speech. My question is on what we had in the very beginning. Is there any cost, the calculation strategy of cost of downtime?
My answer will be very, very easy. Depending on your business, you have to calculate it. So, you know, sometimes to make calculations of downtime, it's very terrible from money perspective because in downtime, you not only to lose the current potential customers, but also brand of your applications, brand of your company. So it's, for example, if Amazon.com will go down for 15 minutes, how many people will not able to buy something? It's real money. But how many people will not back to Amazon.com because they was not able to buy something on Amazon.com for last 15 minutes? So you see, like, this is different. Sometimes calculating of downtime, it's not only the money, what I show on the second slide, that in Fortune 1000 companies, every year they lost 1 billion plus money, but it's only money. But what about brand? And sometimes it costs much more compared to the money.
Thank you very much.
It was the last one question. I expected that you have like, I don't know.
No.
It was the best one. Okay.
Okay, so we have questions up there. So let's go in this row, and we'll be back here.
But based on
Can you
our
raise? Okay, there. Okay, 1, 2, 3, 4. Okay, so a lot of questions. Let's start from here.
I have the same question about the cost,
Okay.
But differently.
Okay.
So every business asks like, how much?
How
For
much
example,
what?
yeah, you said you will lose, but for example, if I make high resilience,
Okay.
business also will need to calculate how much will it cost of high resilience. Let's say I should I'm architect, I should go to the business and say, okay, if you want 99.7, you need like normal regular pricing. If you 99.8, you need like 50% of budget. If you want 99.9, you need 100%. If you need like, I don't know, zero downtime, it may cost me maybe like 200% of my budget. So how can do you have any approach of calculating it?
So first of all, I want to highlight it, just like let me back to this slide where I showed about disaster recovery, because in disaster recovery, it's one of the best way how to understand money perspective. Where it was, sorry, readiness optimized, blah, blah, blah. It should be, yes, it's here. So from disaster recovery, it can be calculated on this way. So if you ready that you will lost, I don't know, data for last 4 hours, for example, or 8 hours, maybe it will cost for you, like, for example, $100. But if you want to have, like, as you mentioned, 4 nines availability or 5 nines, which is not possible, so maybe it will cost for you $100,000, depends on. But if you look carefully at my presentation, I show you some patterns which will not cost some money for you. So, for example, circuit breaker, it's not a money, it's just you have to put in your backlog that if your application currently is slowing down and you continuously have more and more requests, maybe it's a good time just like to close connection to your applications or apply throttling, for example. It will cost for you something. Yes, it will cost development process to do it, for sure. But from resource perspective, no. Do you need to create a good monitoring to quickly detect the problem? Yes, it will cost for you, but it will not cost like for sure, if you will do everything in AWS, maybe it will be a big deal at the end of the month. But if you can apply some open source solutions, like, for example, I'm a big fan of Prometheus, Grafana, for me it's cheaper and easier to do it. Again, it helps you to do it. House engineering. It will cost for you, yes, for sure, it will cost for you. But these patterns help you to make this muscle memory that's in case if something happened, I can recover from this like $100, but make it quicker, not like during the next 8 hours, maybe during the next 1 hour, because I did it 3 times during the last 3 months, not like never. So my experience, I will share my experience about backups. It was a really huge customer, 10 million users, and we did backup solution for our MS SQL. And you know what, like in some period of time, like when we had an issue and we had to restore, we was not able. You know, like we was not able, so we lost this data. So like, why? Because we like did every day backup, every month backups, store somewhere, pay for these backups, but never tested. Yes. People split it, and you know, like on different areas. Who never do backup, people who does backup, and who test the backups. So my main talks of this, like the main idea of resilience, also some patterns which you can apply it without the money, and for sure you have to be prepared, like house engineering. You can test your procedure of recovery, patterns, circle break it, and so on.
Viktor, it sounds like a pretty good topic for discussion during the lunch, so I think we can move on to other questions. I will take probably 1, 2, 3.
Okay.
And yes, we need the break.
4.
Yes.
4. Yeah, I see one person wants to ask one more question.
If we are talking about, one moment. If we are talking about database, something like vanilla Postgres in the cloud,
Okay.
How we can ensure zero downtime and increase performance? Geo-distributed sharding or with replication?
I get the question. So your question related to deployment strategies, and if you have vanilla Postgres, how you can apply deployment for Postgres? Yes?
Yeah.
So with databases all time, it's very interesting question. I would say that currently, for example, in AWS, in RDS, we have blue-green deployment inside in RDS. What about vanilla Postgres if you want to install it in your own EC2 instance? it will be a challenge for sure. So in my case, how we did it, we try to apply these procedures as we store the difference between like the current state, we start deployment process. Store somewhere the difference, what's happened during the deployment, deploy new version, and apply this difference to new version of database. But it's only apply if you want to do some schema changes and so on in Postgres in your database for sure. But if you work with NoSQL and other databases, most probably you will not need to do some deployment with downtime, with schema changes and so on. And with schema changes, it's also a very hot topic, and everyone said like depends. What you should do first, make deployment on your database or deploy a new version of the code. I am part to deploy a new version of the code, and your code should be prepared to work with old version of the database and new version.
Okay.
I hope I answer the questions.
Yeah.
Okay.
Thank you.
Next.
All right, so we'll take one from here and one from there, and that will be it.
Viktor, thank you for your speech. I have the following question. You've mentioned multiple patterns, speaking about managing resilience and availability of the applications. So my question is, don't you think that it's will be correct to mention such patterns like SOA requirements and performance and load testing, speaking about these problems?
Yes, why not? So you know, like it's so huge topic to speak about that. I mean, like so many different patterns. I try to collect most useful patterns which you can apply and make it more resilience of your applications, like what I shared here. So backoff of retry and so on. Performance testing or some SRE practices, for sure, you can do it. But it can be very difficult to put everything in one place during the 45 minutes. So, but short answer, yes. Performance testing is special. It can be very, how to say. So I did it, performance testing, again, like for this customer with 10 million of users. So for every new release, we run performance testing. But performance testing, it means like you need to have absolutely the same environment. It can be cost you twicely to compare it to the normal situations. So not every customer is ready to do it on, on a regular basis. Again, depends on what the size of your customer application and so on. And budget. One of the main questions is the budget.
Hi, thank you for your presentation and touching those nice patterns. My question is how and do you encourage developers in AWS like not to over-engineer and use all those patterns, and using all those metric systems, because sometimes it's like not needed. Thank you.
In our case, sorry, it's needed. Like every time when we have some outage of AWS, I remember my, I just joined to AWS 2.5 years ago. It was 1st of September, and it was 2021. And in 2021, if you remember, we had we have an issues in December in 2021, 2 times. And all of my friends made a joke, Viktor, please stop. Please stop do it. I mean, like, you currently on onboarding, it's your probation period, please stop breaking AWS. So, we affect the whole world. I mean, when AWS does not work, sometimes it's not only affect AWS, because in AWS we have thousands of the customers and rely on our infrastructure. So for that reason, I said sometimes, again, one of our main development pattern or culture, I would say culture mostly, you build it, you run it. You decide it based on the current load. For sure, if we have some of the services where, I don't know, like only 1,000 customer, we don't need to do all of this overcomplicated. Some best practices, for sure, but not to make so high available, blah, 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 all of the stuff, because in this case, we will affect only 1,000 people. But if we look, for example, RDS, or EC2, or DynamoDB, or IAM, so if we have the problem with this kind of the services, most probably will affect like 80% of whole customers inside an AWS. We have to do very, very carefully with that. For that reason, I shared here, like we have checklist. Sorry, it was on the start when I said like in AWS we have a checklist, this operations readiness review. So for every new service, we have this checklist, and people, when deploying something new to the production, they go through this checklist. It's not the cutting edge, it's just like checklist, but you go through this checklist.
All right, let's choose the best one, Victor. Which was the best? But I still see some hands, and I do appreciate it. So our speakers will be downstairs during the break, so I really encourage you guys to approach them and further go with your discussions if you want to.
It's the best question with from 10
The very first one?
Yes, the first
All
one.
right, sweet. So he will be getting 2 gifts from us, the Resilience Builder cards and a 1-year full subscription to JetBrains. All right.
And for sure, if you have any other questions, I'm still here.
Yeah.
We can continue our conversations, discuss all of these patterns. Are you agree, not agree? What you do in your productions. We'll be very happy to hear about that.
And he's probably the easiest person to find because of his shirt, so I'm sure you'll find him. All right, give it up to Viktor Vedmich, developer advocate at AWS. Thank you, Viktor.